We have a very exciting hour ahead of us here today. We are joined by representatives from many programs in engineering offered here at Lund University. My name is Jönsson. I work at the Division of External Relations at Lund University with student recruitment and marketing as well. Today, I will be moderating this session, and I'm going to try to distribute the questions that we receive as equally as possible among the panelists, of course. And they're all going to introduce themselves in a little while. I would like to ask participants who are still joining, I can see, to, if they have questions, and I hope you have questions today for us and the panelists, please use the Zoom Q&A to ask your questions. The chat has been disabled for participants, so please do not try to use the chat. Instead, try to use the Q&A to post your questions. We also have a colleague called Timothy Parker who will have a look at the Q&A during the presentation or during the webinar and answer many of your questions there as well. But maybe without further ado, I would like to introduce or invite our panelists to introduce themselves. We have, starting in my top left corner, Mr. Linus Zhang from Water Resources Engineering. Linus?
Yes, thank you. My name is Linus Zhang, and I'm a program director of Water Resources Engineering program. As you might see, my name is not a typical Swedish name. That is true. I'm a Chinese, and I have got my PhD at this same specific topic in water resources engineering many years ago. So now I'm taking care of this program. Nice to meet you all on cyberspace. I hope you will have many questions.
Yes.
Thank you.
Thank you, Linus. Yeah, good idea to remind our visitors to use the Q&A function of Zoom to ask interesting questions to our panelists here. Next person to introduce herself and the program she represents is Jenny.
Hi, everyone. Thank you very much, Johan, for inviting me and for taking part in this exciting afternoon. I hope many of you are out there joining in. My name is Jenny Schelin. I am the program director for Pharmaceutical Technology, Discovery, Development and Production. One of the longest names, hard to remember. Pharmaceutical Technology will do. I'm an associate professor in applied microbiology. I teach a lot in regulatory affairs and QC, QA, quality assurance in pharmaceutical industries, and I work a lot with the pharmaceutical industry. So I look forward to your questions. I hope you have a lot. Thank you very much.
Thank you, Jenny. That's very interesting. Participants, please use the Q&A, as I said before, to ask your questions. Next up, we have Mr. Håkan Jönsson.
Hello, everyone. Yes, Håkan Jönsson is my name. I'm glad to see that there's so many prospective students interested in our programs. I'm the program director of the EIT Master of Food Systems, which will be given for the very first time at Lund University for the next autumn. But the program in itself is already up and running. It's a collaboration between different European universities, and you will also be able to switch between different European universities in this rather unique university and industry collaboration throughout Europe.
Right, thank you, Håkan. Yes, we're very proud of this new master program here that we are partly responsible for together with other European universities, the EIT Master in Food Systems. We also have with us here for today, representing virtual and augmented reality master program, Mr. Matilda Svalergold.
Yes, hello everyone. And as Johan said, I'm the program director for the master's program in virtual reality and augmented reality. And I'm an associate professor who have been working with VR and AR research for more than 20 years. And my main research interest concerns human-centered design of virtual environments.
Okay, thank you very much, Mattias. We have received a few questions in the Q&A so far. They are mostly kind of general, I would say, but there is one person who is asking about the current work and research that you, the panelists, are involved in at the moment, because you represent for different master's degree programs, but maybe you are also doing research on the side. Is anyone particularly interested in explaining what type of research they are currently involved in? Linus, are you doing any research?
Yes, yes, sure. It's very common in Sweden that as a professor or teachers that you do the research, teaching, and take care of the master programs at the same time. So I'm currently running several research projects as well. That is, of course, dealing with water. So our hot topic is always water. And the water is, of course, as the philosophers say, that's the starting point of everything. So it is super important. We have challenges now in the coming years, a lot of challenges due to the climate change, water shortage, extreme weather conditions, and so on. So many of these challenges are directly related to water problems, either flooding or water shortage or water quality or whatever. So it is very much related to the UN's Sustainable Development Goals. In these goals, 17 goals, you can easily identify half of them are directly related to the water issues. So it's a very hot topic that we are doing. Thank you.
Thank you, Linus. And also I should remind participants here that water resource engineering, this is a master's degree program that has been running for quite a long time at Lund University. So we have a lot of experience in this area.
That's right. So more than 20 years.
More than 20 years. Yeah, that's good. Thank you. Jenny, would you like to introduce some of your research if you are currently conducting research?
Yes, I do. I would love to. I'm a food microbiologist, actually, but I work a lot with different pathogenic bacteria causing different type of illnesses, very heavily related to the pharmaceutical industry, of course. And one of my research projects concerns the testing of new small organic molecules as potential drug substances and their effect on bacterial growth in different conditions. So here I'm collaborating with the organic chemists at our department that are also involved in the organization of this master's program. And they produce different kinds of small organic molecules that I introduce into bacterial systems and measure growth and other behavioral characteristics of these microorganisms to see if they can have an impact, and thus maybe work as a replacement for antibiotic substances that we all know are increasingly problematic due to the increase of resistance towards antibiotics. So that's one part of my research, and that is actively ongoing at the moment. And the collaboration between different areas, microbiology, organic chemistry, is something that I would say signifies us in the work in our department to have this cross-disciplinary approach. And that is something that is also reflected in the program Pharmaceutical Technology, where we are 3 different departments sharing the organizational structure of this program. And we really try to introduce that into the program so you have a feeling for all different areas that are related to the pharmaceutical area.
Thank you. And can I just, as an add-on question, because this is a rather cross-disciplinary program, as you said, does that also mean that students from different backgrounds can join, or do you have to have one specific background?
No, you can have quite a different type of background, as long as it's of an engineering type, because we are basing a lot of the courses on mathematics. So that's where the core issue is. But you can have chemical engineering, biotechnology, chemistry, medicinal chemistry, or equivalent as a background, because the students in here in this program from Lund University, they have all these different types of background joining up. So as long as the engineering aspect is there with the mathematical basics, it's open to many different directions.
Okay, thank you very much. And then we have Håkan Jönsson representing EIT Master of Food System, which is a new program. Are you currently conducting research, Håkan?
Yes, I am, and unsurprisingly, it's connected to food. My background is actually in the humanities, so I'm working with different cultural aspects of food. One such thing is what I call the cultural heritage of a circular food production, trying to draw on learnings from the past in order to create a more sustainable food system of the future, basically. And I'm also involved in European interdisciplinary projects on the future education for professionals in the agri-food sector in Europe. So basically doing research on the type of new educational programs, which this program is one part of.
Okay, thank you, Håkan. Mattias, finally, virtual reality and augmented reality. These two phrases are very exciting, aren't they? Can you explain what do you do there? What type of research is being conducted related to virtual reality?
Yeah, that's a very good question. I can tell you something that happened rather spontaneously during the pandemic. Some of you might remember that people started to talk about something called Zoom fatigue in the middle of 2020. People got very tired of sitting in video meetings 8 hours per day. And why is that? So we asked ourselves the question now, if this is not very compliant with the human brain, what would be? So we started to work in VR, which sounds hilariously strange. And it is in the beginning. But we continued for a couple of months and studied what happens in a group of people who try to do tasks together in a virtual world. How does it affect creativity, efficiency, social interaction, etc., etc. And yeah, we just started to scratch the surface. This is a completely new research field, and I think we will see a lot of more applications concerning working in virtual environments in the future. People are talking about the metaverse, for example. That's part of this movement towards new ways of working.
But so related to your research and also education, can students in any of these programs that are represented here today expect to learn about the very latest cutting edge research findings in your respective areas? Linus, what do you say?
Of course, the short answer is of course yes. Yes.
All right. Yeah, thank you.
We always try to bring in the latest development into our courses and the diploma project and so on.
Okay, Jenny, what do you say? Is it?
I fully agree with Linus, and as Linus already mentioned, we always have a dual role in our profession here. We are always researchers and teachers, and there is a reason for that. And that's exactly this, that we should bring in the cutting edge research to have the top of the line knowledge for you students to acquire. And in my program, for example, there are several project courses where the projects are actually located within the different divisions doing this research, and the projects are within the different research topics going on at the moment. So we are trying our very best to give you this in different aspects, both at the theoretical lectures and in the practical parts by the researchers performing it.
I will come back to this, but first I would like to introduce Mr. called Arnold, representing the master's program in Photonics, I believe, to this webinar. Welcome, Cord.
Yes, thank you very much. I had a double booking and a lecture until now, so I couldn't come earlier.
All right, well, thank you anyway. We're just discussing kind of the connection between ongoing research and the master's degree programs that are represented here today, and what students can expect to learn in terms of, you know, the latest findings in terms of research that we also conduct at Lund University. Mattias, how do your master students get exposed to research, and how do they learn about the latest findings in virtual reality, for example?
We have a very well-equipped laboratory, virtual reality laboratory here at Lund University. And we're lucky enough to have enough funding to buy the latest equipment. which means with cutting edge equipment, you can actually do cutting edge research. For just take one example that students have been working with. If you, for example, have a virtual reality headset with built-in so-called eye tracking, what could you do with that? Could you, for example, have a person with no motoric capabilities at all navigate virtual worlds just with eye movements? That's one challenge that we have given students that they have solved in an excellent way. And yeah, so I think the laboratory as such is a means for very good research.
Right. So we have top facilities, basically top labs. I don't know if we should brag that we have a lot of money, and it's it's a double-edged sword. Because, but I think it's good. We do have quite a lot of funding for engineering and science. Medicine will be probably the typical 3 areas. I guess most comprehensive universities have that in common, perhaps. What about the EIT Master in Food Systems, Håkan? Can students expect to learn about the latest research findings that are relevant?
Yes, of course. I think that's a feature of basically the entire university, that teachers, they are always involved in good or even excellent research within the system. And I mean, within the EIT Master of Food, you will also get exposed to other universities, since you will be going to other European universities, actually partly based on your own choice. Also, with the equipment, we have a pilot hall for food engineering and food production, which you also will be able to interact with. And then, of course, not least, when you are working with your master thesis project, you will be exposed both to cutting edge research and industry, or partner, or develop your own entrepreneurial idea based on research.
Can I just ask, because of the EIT program, of course, is offered at many partner universities in Europe, is there any special subject or topic that the students focus on if they come to Lund in this program?
Yeah, we say we have the profile in sustainable food production and packaging. So it's the production and packaging area that is sort of the key feature of studying here. And then you will, depending on, I mean, you can choose different paths, basically depending on which other universities you want to go to, say Madrid, Warsaw, Hohenheim, Torino, etc. So, I mean, go and browse and check out the different paths that is possible to apply for, because then it will be possible to find your own and develop your own profile within food systems education.
All right, thank you. Mr. Arnold, would you like to describe, I mean, photonics is an area where I assume there's a lot of research. It's a research intensive subject, isn't it? So students can probably expect to be exposed to quite a lot of research and research projects, right?
Yes, in our case, all teachers from the program are active and successful researchers, and we usually try to bring our research also into the courses. Of course, there are some basic courses that we start with, that do not necessarily change based on the latest research. But even in these courses, we try to make connections to what we actually do. And this program is embedded in a very strong area that is based around the Lund Laser Center, where we have, which is the Lund Laser Center has several different actors. It's not a physical center, but it's a collaboration of several institutes around some of the faculties at Lund University. So it's a very strong center in optics and photon science. And then, of course, we have couplings to the synchrotron as well. And right. I would say research usually enters strongly in our program, and in particular then when the students do their master thesis. So during the courses, they get to know the relevant teachers, and I guess where it clicks the most, or where they find the the strongest interest, they would then come to us and ask for their possible master thesis projects. Otherwise, there's of course always a possibility to go to industry. So even here in Lund, we have companies that strongly rely on optics, like for example, Access is one of these, and we had a few times students who chose the industry master thesis, and a few times it was also at Access. So this was a possibility to also expand our own horizon as teachers, and to learn, of course, together with the students about how the work in a modern company works today.
Right. I think that's very interesting, because a lot of students we know, they are interested in, I mean, some perhaps would like to stay on in academia and pursue a PhD degree after they finish their masters. But a lot of students, of course, want to join the industry where they have pursued their master. I mean, maybe private sector company, most likely. So what would you say? Cord explained that they had some collaboration with Access, for example. Jenny, what about the Pharmaceutical Technology program? How do you collaborate with industry? I mean, the pharmaceutical industry in this region is very large, isn't it? Not least on the Danish side.
Exactly.
Yes. How does it work?
Yes, you're perfectly right there, Johan. We are in a hub of pharmaceutical companies, small scale, middle-sized to the big giants. And the big giants are mostly on the Danish side, but just a bridge away. And we have a very close connection to this entire Copenhagen area as well. And here in Lund, we have the Medicom Village area that was replacing AstraZeneca when they moved their facility to other locations. And we have a lot of small startups and all the way up. And in our program, we start off with having a lot of guest lecturers from the pharmaceutical industries. They bring in the actual topics into the industrial context, into the courses, the ones having the true experience. Then later on, master thesis projects are very well possible in this area as well. And we also have an advisory board in this program that is 5 different pharmaceutical industries represented, that we talk to on a regular basis to make sure that the content of this master program is up to date with what the industry requires in the engineers that they want to hire afterwards. So we always have a constant dialogue in this way. So we really work to have an ongoing dialogue with industry throughout the program. And we try to have some social events regularly where we invite industrial persons to come for an evening seminar where we can have a presentation and a discussion afterwards. So that's some examples. I hope that answers your question.
Yeah, certainly. Mattias, may I turn to you now? Virtual reality, what can students expect in terms of potential collaboration with industry, or what types of companies and industries are most relevant for your program?
Well, until a few years ago, it was mainly small startups and consultant companies that worked with virtual reality and augmented reality. But this has started to change the last couple of years. So now what we see is also the big companies are looking for competence in this field. Then I mean companies like Ericsson, Sony Mobile, Volvo, and so on, local companies here in southern Sweden. Then, of course, there's the vicinity to Copenhagen. There's a huge VR AR scene there as well. For example, the big company Unity, who delivers development platforms for developing VR and AR applications. Also in the town of Malmö, just 20 kilometers from Lund, you have a lot of game studios, and it's said that Malmö actually has more game studios per capita than London, for example. So it's the gaming industry is huge there, and it's easy to to see the connections between VR, AR, and gaming, of course.
Yeah.
So I'd say it's the future looks extremely bright if you get an education within VR and AR, definitely.
Thank you, Mattias. Linus, you represent a program that has been more than 20 years of history. Where your students, do they have connections with industry or government, or what types of positions and industries do you collaborate with, or can you elaborate?
Yes, yes, I can confirm that it's also the case for us. In Lund, for instance, there's also a hub, or in this idea science village. We have a lot of contacts at the network companies there, where we have kind of networking with almost all large and small scale companies, and also international organizations, consultancy companies, private companies, and so on, and even local and national government agencies. So our students usually go to these industries. So maybe 1/3 of our graduates will go for a PhD study, and 1/3 will go for this kind of industry companies, and maybe another 1/3 will start up their own business as well. So it's roughly divided in this way. So yes, we do have quite a well-functioning networking with industries. So many of our master thesis work are done in cooperation with them, jointly to carry out something that the companies are interested. Thank you.
Right, thank you, Linus. Håkan, I have a question for you. I noticed in the Q&A there are quite a lot of questions. I'm not entirely sure that you're able to explain the differences, but people are wondering about the EIT Master of Food System and the Masters in Food Technology and Nutrition at Lund University. So the Masters in Food Technology and Nutrition is, of course, just the Lund University program, and the EIT is a collaboration. But is there anything else you would like to try to explain about the differences between these two?
Yeah, I mean, first we can take the practical aspects, and that's rather important, that if you want to apply for the EIT Master of Food System, you don't apply through the regular Lund University or Swedish University application portal, but you go directly to the EIT MFS application portal. You will find links on our website. So that's one difference. Another difference is, of course, that you don't have the mobility aspect in the Food Technology and Nutrition Masters program. You will be based in Lund all the time there, and it's not the same collaboration with other universities. But there are, of course, also a lot of similarities. Both programs are very tightly connected to the industry and external collaborators. You will have lecturers both from very good and excellent researchers and from the industry. There is also, similarities when it comes to the focus on the long-standing experience of food technology, and with the practical application, the pilot hall, and so forth. So, it's take a look at both and see which will fit your profile and see where your career prospects in the future. There is, of course, also a slightly broader approach in the food systems program versus the food technology and nutrition program. That depends also whether we are more interested in the systemic aspects of the food system and the entrepreneurial stage, or if it's the food technology and nutrition that is what you are really aiming for in the future. So take a look at both. They are both, of course, very good options for a future career, and you will have a lot of fun, no matter which program you will choose.
All right, thank you. We have quite a lot of people asking or writing in the Q&A. Some of the questions are kind of similar or overlapping. I have a question here. I think it's for Jenny. There is a person saying they got a Bachelor of Science degree in Pharmaceutical Science from Egypt. All my studies related to Faculty of Science and Faculty of Pharmacy, where here it's related to engineering. Is this person able to possibly join your program in Pharmaceutical Technology despite not having a degree in engineering?
That's a very relevant question, and I will try to clarify. The engineering aspect is mostly towards the mathematical pre-knowledge that you have. In many classical pharma related educations, you don't have that much math. And if you do not have that, then you will not be able to fulfill our entry requirements. So read up carefully on the entry requirements regarding this specific aspect. And the reason for this is not that we do not want to welcome you, but in order to be able to follow our courses, you need this level of pre-knowledge in mathematics, since this program joins up with the existing students at Lund University and the Faculty of Engineering, and they have this program. And since this is an engineering faculty, the courses are, of course, within this area also tuned towards engineering. And pharmaceutical technology is very much about engineering. So you need these mathematical skills above all. Then, of course, you need other pre-requirements that are also listed in the program description, but the mathematics is the key here to this question. So pharmacy, sometimes they do not have that, but then maybe you can acquire that in another way before you apply.
Yeah, I think the student never really explained how much mathematics he or she had studied previously, but it's a very important point to look at the entry requirements of our programs and make sure that you actually fulfill them completely. Otherwise, we may not consider your application.
No.
I would like to ask Mattias, what type of academic backgrounds are you looking for in your students for the virtual reality program?
Since the program has a lot of courses in computer graphics and computer vision and such, you need a background in computer science or computer engineering or something similar. And you need a good set of courses in mathematics, of course, calculus, the linear algebra. The linear algebra is absolutely fundamental for computer graphics, for example. You need knowledge within systems and transforms, and also probability theory and statistics. So for at least 30 credits. So yeah, you also need some basics in object-oriented programming. So those are the requirements that we have.
So you must know some programming language, object-oriented, you said.
Yeah, exactly. It doesn't have to be one or another. You need to have the object-oriented programming thinking, so to speak.
Okay. Cord, can you explain in your program what types of students are welcome? Because maybe you have one leg in the Faculty of Science and one leg in the Faculty of Engineering, if I'm not mistaken. Or can you explain the relation between?
Yeah, you actually, the Department for Physics is a bit particular because we have both faculties here. The Department of Physics has both institutions that belong to LTH, to the engineering faculty, and institutions that belong to natural science. And locally here, the division in what we do is very little. So what the research that we do at Atomic Physics, where I'm located, and at the Lund Laser Center, you would find in other places, both at engineering faculties and natural science faculties. And what we usually look for for the students coming to our program is to have a bachelor degree that is either in science, and this would then mostly be physics, or in engineering. And this is often applied, like for example in optical communication. It could also be in electrotechnology or so. So we are rather flexible. So I think we can accommodate both students with engineering background and students with natural science background. And this is usually what we take in. We have some preconditions on calculus, like also what Mattias said. So you should have a solid background in mathematics. And we also require some background in actual physics. And we highly appreciate some basic course in quantum mechanics, which is essential for some of the things that we do, in particular for the students that come in with bachelors with very applied engineering. We sometimes have to look at their pre-education, in particular in terms of quantum mechanics.
Quantum mechanics.
Yeah, but we can usually adapt to this.
Right, but at least it is possible for both engineers and science major backgrounds to join the Photonics Master. Absolutely. If they fulfill these requirements that you have discussed here.
Yes.
Linus, at your program, Water Resources Engineering, what types of backgrounds do students typically have, or what are you looking for?
Yes, similar to the other programs, our program, Water Resources Engineering, we belong to the faculty as well. So we have a strong to the engineering as well. So that means that we also require advanced mathematics in our entry requirement. What we are looking for are the students that have a background in, say, civil engineering or environmental engineering with a direction towards water. So to be more specific, in our entry requirements, we have 3 important courses listed. That is advanced mathematics with the calculus, linear algebra, and so on. And then the second course is hydraulics or fluid mechanics. That is directly something dealing with the liquid, with water. And a third course that we require is the geology, because we need also sooner or later the knowledge of geology to deal with all the water problems that are in our ground. So these 3 courses we look specifically for our applicant. But if you have a background in civil engineering or environmental engineering directed to water, normally these people they will meet the requirement. But for some reason you are missing one of these courses, then of course you can try to acquire that course in the other way as well, as Jenny mentioned. So it's possible. But we will look at these 3 courses in the entry requirement when we evaluate the applicants.
Right, so you would check the transcript to see that they have studied the right courses. Håkan, if we move to the EIT Master of Food System, do you also just narrowly admit students with this engineering background or science, or is it more a combination or a variety of backgrounds that you're looking for?
Yeah, I think it's slightly more open, but I mean, the basic requirement is a Bachelor of Science degree, but that can be in food science, chemistry, food safety, nutrition, agricultural science, biological life sciences. And there is also an opening for that relevant degrees in other fields may be considered by the admissions committee on a case-by-case basis. But then, of course, you need to, demonstrate that you have equivalent skills to enter the program. But perhaps it's slightly, at least slightly broader than many of the other engineering master's programs.
Okay, thank you. We have quite a lot of questions here. Maybe from an Indian student, Håkan, again, what do you reckon? I mean, it's the EIT Master in Food System. It's just launching, isn't it? I mean, it's kind of a new program that students can apply to. But what can you try to guess? I suppose what the job market for a student with a degree in this program eventually, what will they will it be easy to find a job, I suppose, is the right way to frame this question. In India, maybe it's difficult to say if you don't know much about India, but overall, in anywhere in the world, we can say.
No, but I think in general the job market is very good, and I mean it is a good label, certificate of labor to have gone through a master program with the EIT label, and there you also have quite a diverse job market. I mean, it could be large multinational companies, it could be smaller food companies, but I mean food systems knowledge is also relevant when it comes to international organizations and governmental and non-governmental organizations. So with the network and the potential to develop your own profile, I think, I mean, we can't say much more detail, and we don't really have an alumni network yet, as you may expect, since we will start next autumn. But still, I think the prospects for job opportunities will be good, because it is a good job market in general, and also with this food systems and entrepreneurial angle, it has been initiated by several actors, not least the food industry. Yeah.
Okay, thank you, Håkan. I want to, because the clock is ticking, there is so much to say. I think 1 hour was a bit too short probably, but we have 18 more minutes to go. And I would like to discuss with all of you what students can expect when they show up. Let's say they fulfill the entry requirements, they make an application, you like them, they join us. What can they expect when they actually come here? How much is, for example, theory and how much is more practical, get your hands dirty work in labs or even outside? What's the division between theory and practice? Jenny, in your program, how much time do they spend reading books and how much time do they spend in the lab?
Well, that's a tricky question. We have a few compulsory courses that all students in the program have to take, actually 5. They are mixed. One is completely theoretical in organic chemistry, and then the rest always have some kind of lab. This signifies our program. Lab work is crucial to understand the knowledge in this area. So I would say, I can't say in division in percentage, because that depends then a bit on which courses you choose as your elective courses, where some are more theoretical and some are very practical. But also in the project courses that are mandatory, it's a big part of laboratory work. So you will be in the lab for sure. I can guarantee that. And the lab knowledge is at the core of the knowledge that you need to acquire in order to understand all the theoretical part, but also getting the hands-on practice to really understand what it is to calibrate this instrument or to use it or to produce data in a robust way, and also all the detailed skills that you need to know before you enter the industrial job market later on, maybe, or if you want to move on as a scientist within a research project. So in our program, it's a very practical aspect. In addition,
a lot of time in the lab.
Yes, and it can be long days sometimes.
Yep, so that's good.
But that's usually the most appreciated part of the courses as well.
Cord, what about your program in the Masters in Photonics? Can you describe how much? I mean, you don't have to say a division between reading books and tinkering away in the lab, perhaps, but is it a very practical program where you need to use your hands and your head?
I mean, all of our courses have certain labs. So this we believe is very important to not just learn theoretically about the different techniques and technologies and only see them in the courses, but also to get the possibility to try this in a lab setting. So usually most of the courses have 2 or 3 labs during the course that are often being balanced with usual exercises, or also with computer exercises, or in the case of some of the photonics courses, we also have ray tracing exercises, so where the students are supposed to design a certain optical system, and each course has its own projects. And so this is an activity that goes through all of the compulsory courses. So the program has 4 compulsory courses that go for the first year. So there's 1 compulsory course per term and a second elective course they can choose from. But the idea is that they go through this chain altogether, but they have some possibility to follow their own interests for the second course that they can take in every term. And then for the second year, it's totally free. One thing that is also very popular among the students for the second year is that we have opened a possibility to do a 1-year master thesis at half speed. Because in the master thesis that we usually set up in our research areas can potentially be very high level, and also in particular often you have to wait for some of your pieces. For example, if you're supposed to build an experimental setup and you first plan the setups and you order all of the things, then this is usually very complicated to get done in the usual time that you have for master thesis at LTH. That would usually start in the beginning of January or middle of January and end in the beginning of June. So if you think about the journey of a master student will usually start reading the master thesis as the first 2-3 weeks. The student will start reading about the topic and get more into the depths of the topics, and you would start to do your experimental work with some supervisor. And after 3 weeks of this, you would start to be effective yourself to do experiments and actually do the core of your work. But then actually it's almost time to start writing. So this is often a very short journey, and this is why we have opened for the possibility to do a master thesis at half speed, where the students are being associated with a research group for a full year. They do courses at the same time, but they already get an office together with a research group and work on a research project for a whole year. Only at half speed, but still for a whole year, which is a very good way to get much deeper into the topic and to bridge for example, delivery times and ordering times and things like that. And this is something that that is very, very popular. After we reopened the Photonics program now 2 years ago, basically all of the students have taken this possibility. The only requirement that we need to have is you need 60 ECTS to do this. So basically, the students that manage to do all exams or pass all exams in the first year have the possibility to start the master thesis in the beginning of the second year.
Very good, thank you. Yes, finish all your courses the first year. That's important.
Absolutely. Anything you take into the second year will be in conflict with other things. So
yeah, right.
Usually, if I see that the student doesn't sign up for the exam, I usually contact them and try to explain the importance of doing things in time.
Yeah, thank you, Cord. Mattias, your program, I expect the students play a lot with computers, I suppose, and experiment with virtual reality headsets, etc. Can you describe the division between more theoretical kind of knowledge and the more experimental or lab-based exercises?
Yeah, we try to achieve a good balance there. And I'm afraid to say the program starts rather theoretically, but we try to balance that with visits to the VR lab, so the students still get some hands-on experiences of all the equipment we have. But after this theoretical beginning with computer graphics and image analysis courses, we start with an interaction design course. And this is where you really start to work more in a more practical way, designing different types of user experiences and user interfaces. And then the second semester, we start the big VR course, which is one of the so-called flagship courses we have. And in that course, you really get to play around in the VR laboratory. And that course has a mixture of theory and the practical projects and assignments. And after that, there is a theoretical course, interaction design, as a complement to the more hands-on course that they just had, and so on and so forth. So we try to achieve some sort of balance here between theory and practical moments.
Thank you, Mattias. Linus, is it the same water resources engineering? You learn theories, theoretical knowledge, and then also some practical components in the program?
Yes.
As well?
Yes, exactly. We are also striving to combine and balance the theoretical part with practical things. So we have, say, 45 mandatory courses a year, and then another 45 elective courses, and then plus the 30 credits degree project. But we try, even with this mandatory courses, we try to combine other things, not only labs. Not all courses have labs, but we have, say, group work, project work, even debate session or discussions and so on, and some computer modeling as well. So it's a combination of different activities. So it's not just sitting there and listen to the lectures. We combine different activities for all our courses.
I have a question, because many of you have mentioned elective courses, and many master's programs in Lund consist of a combination of mandatory and elective courses. Can you just briefly explain in your programs what types of elective courses that students can choose from? Do they have to be in a very narrow field, or are they free to choose from a broad range of courses? Jenny, what do you say in pharmaceutical technology?
Yes, I think is a very relevant question. Besides the 5 mandatory courses that give the basis of this knowledge area, we also provide a few different alternative, I wouldn't say tracks, but anyway, way to focus. One is the more organic track, one is the biopharmaceutical track, and one is the analytical track. Because these are 3 main fields in the pharmaceutical area that you might work with later on. So if you're more into the organic hardcore synthesis part, you are able to choose elective courses towards this area. If you're more of an analytical chemist, you have courses that address this topic more in depth, apart from the mandatory parts. And if you're more into biopharmaceutical area and the immune technology area, you also have an elective course to choose here. So we hopefully cover all the different interests that our students might have and are able to prosper in when they come to the elective part of their program.
Thank you, Jenny. Håkan, may I turn to you? The EIT program, of course, a collaboration between several different European universities. Do you have electives at each university, or does a student have to go to a different university depending on what they are interested in?
Yeah, I mean, the most important selection you do as a student, that is the path you choose as your preferred option. I mean, which profile and thereby by which university you are going to during semester 2 and 3 of the program. And then it's slightly different between the different universities. Some have a lot of elective courses, some have only mandatory courses, and others are a little bit in between. So I mean, it's difficult to get the very short answer on the proportion of elective and mandatory, but I mean, you have an opportunity to develop your own specific profile. That's for sure.
Right, so the student can shape the program into what they want to achieve, basically, or do during their time as a master's student. Mattias, is it the same at your department, or is it just mandatory courses, or
Our program is a little bit strange in the sense that we only have mandatory courses. Having said that, however, we are currently looking at possible elective courses for the future. For example, in photorealistic rendering and machine learning. However, these are very popular courses, so there's some sort of negotiation here if we can actually put them in the program or not. So it's a work in progress, I can say.
May I ask, is this based on student feedback, or is it just something that you kind of figured would be good to offer?
Yeah, for example, machine learning is extremely relevant for everything, basically, but and VR and AR also, of course. So that's something that some students actually have highlighted, that it would be very, very relevant for a program. Yes.
Okay, thank you, Mattias. Cord, you already kind of explained for your program in Photonics, but can you elaborate a bit more on the elective versus mandatory courses that are offered within the program?
Yeah, we have the elective courses, the mandatory courses. This is a chain, and this is what we call the engineering branch of the project that consists of 4 courses. And then we have 2 elective mandatory courses. For the elective courses, we have split up the program mostly into, or roughly into, 3 different branches. One we call diagnostics and interaction. So this is any kind of course that is related to light manipulation or light interaction with different kinds of matters. And this can be very diverse. This can be atomic physics, but this can also be, for example, medical optics, which is a very very popular course in the program. So whenever light interacts with matter, this would fall into this branch. We have a second branch that is optical communication, which groups a few courses from the physics department that are about, or that cover on the topic of optical communication, but also combines courses from more, for example, a lot of EIT courses from that's the division for electrical and information technology. They have a lot of courses about radio technology. Lund is very much radio communication, which, however, is also relevant for optical communication. So we basic courses on radio communication, on channel coding and source coding, we combine in this branch. And the last branch is very much related to our sister master program that is also at the Department of Physics, which is a nanotechnology master program. So we have a branch that is about nanotechnology, where we have a lot of interaction with the nano students. But it is not that the students have to choose one of these branches. It is just that we have ordered the courses into these branches. But they can follow just their interests, and they can make this. They can make their elective courses very coherent by choosing most of them from one of the branches. But they can also totally mix the different branches, just following the interest. And we have made sure that through the obligatory courses in the program, all students get approximately the same background, so that we can easily reach the desired outcome of the program and examine all the things that we need to examine from the program based on these obligatory courses. And then the students have a lot of freedom for the elective courses. And sometimes students come with elective courses that are not part of the program, and then we can usually find solutions. If the courses are relevant, we can usually find solutions that the students still can read these courses, even if we have not put them as part of the program.
All right, thank you, Cord. We're actually running out of time here, but just a kind of a final question to the panelists before we say thank you and goodbye. I would like to invite each panelist to kind of briefly explain to students what they can expect if they join your program. Linus, what can a student who is interested in water resource engineering expect if they come to Lund and they study your program?
Yes, I think I would say that when they are ready here through our program, they can feel that they have all the necessary tools and the capacity to tackle this challenging problems of water and climate change, either in the academia or in the industry or in government agencies. So that's where our graduates usually go. and tackle these problems in all arena, from the global scale to national to local scales. So that is a very much needed knowledge, and the job market is also very good. That is our progress, and we are proud of that. So welcome. Thank you,
Linus. Excellent. Jenny, what do you say? What can students expect when they join your program?
I would phrase it as, if you come to us and our master program in pharmaceutical technology, you will receive a combination of both deep but also broad knowledge that covers the entire pharmaceutical production chain, from the discovery phase in the research lab through the formulation part of actually forming a drug to the large scale production of pharmaceutical compounds. And that also includes the quality assurance and the legislation and the regulatory affairs side of the pharmaceutical industry. And this is in close collaboration and connection to the industrial applications within this field. So I also warmly welcome you to Lund, and I hope to see your applications. Thank you.
Thank you, Jenny. Håkan, would you like to explain to participants what can they expect from the EIT Master of Food Systems?
Well, you can expect to get quite a lot of knowledge and also the tools to be part of a transformative process towards the food system of tomorrow, a more sustainable one. And you will get that both with, say, traditional knowledge, but also with a focus on the entrepreneurial dimensions for you as an individual. And finally, of course, a very good and unique European international network, both between universities, researchers, teachers, and also with other stakeholders, industry, and so forth. Thank you.
Thank you. Now, Mattias, virtual reality, augmented reality, what can students expect when they join?
Well, I would say that they can expect to work alongside researchers as myself, students from other programs, companies, and all of this happens in a very multidisciplinary manner. And we try to focus on working with very relevant societal challenges using VR, AR as a tool, and it can be health applications, sustainability, and so on and so forth. And all of this happens in a cutting-edge VR, AR laboratory. Thank you.
Thank you, Mattias. And finally, we have Mr. Arnold.
Yes, I would say in the case of the Photonics Masters, you will get a very good education in all different aspects of modern optics and photonics that qualifies you either to be qualified for a PhD, to apply for PhD either with us or with any of the good places in the world, or for a good job in the high-tech sector. So this means all companies that work with optical communication, other high-tech companies towards Silicon Valley, and of course also local players. We have had very many students going to Access or to Vioneer, a company working on independent driving, or Ericsson, another one, optical communication. So there are a lot of possibilities to either do a career in science or in industry.
All right,
all of our students, as far as I know, have been very happy with the education that they got.
Yeah. Thank you so much, all panelists, for joining today. This felt like a very short session. We could have gone on, I think, for a little while longer, but here we are. It's 4 minutes past 3 in the afternoon, Central European time, and we have to wrap up. So I would like to thank Linus, Jenny, Håkan, Mattias, and Cord for joining us here today and sharing your knowledge and information about the programs that you represent at Lund University. So thanks to all the participants as well, and we hope that you are successful in your application to Lund University. Thanks, everyone.
Thank you very much.
Bye-bye.
Bye.
Bye. Thank you.
Bye. Bye.
Bye.